You know that feeling, that very specific, uniquely modern kind of frustration? You're using a state-of-the-art AI, this tool that's supposed to be like magic, and it just fails. Not by crashing, but by giving you a perfectly written, grammatically flawless, and yet completely fabricated answer. Well, let's get into why that keeps happening. And there's a phrase for this that just hits the nail on the head: the confident lie. It perfectly captures the two big ways these AI systems break down. On the one hand, you get these incredibly plausible, articulate hallucinations. And on the other, you get these clumsy, canned refusals for questions that are totally fine. And this isn't just a theoretical problem, right? The consequences are shockingly real. We've literally seen lawyers submit court briefs citing fake legal cases that an AI just invented out of thin air. And on the flip side, we have all run into that brick wall, that dreaded phrase, as an AI language model, when we ask something completely harmless. It's maddening. So, that gets us to the big question, doesn't it? Are these just little glitches that we can patch with the next software update? Or is something much more fundamental going on? Are we building these incredible technological skyscrapers on a foundation of shifting sand? That's what we're going to dig into. To find the answer, we need to do a little diagnosis to find the root cause. And it turns out the problem isn't some simple bug you can squash. It's actually a deep structural flaw that's rooted in the very geometry of how these systems are built. We're going to use a framework from cognitive neuroscience called the Global Neuronal Workspace, or GNW. And the idea here is pretty straightforward. If we want to build an AI that can actually understand things, we should probably use the only system we know that actually does, the human brain, as our architectural gold standard. Okay, so when you actually grade today's AI using this GNW framework, oh boy, the problem just leaps off the page. The framework says true understanding needs three things. For condition C0, which is fast pattern matching, today's AIs get an A+. I mean, they're brilliant mimics. But for C1, broadcasting verified info, and C2, knowing what you don't know, they get a big fat F. They're basically trapped in a state of pure mimicry without any real self-awareness. But here's the real kicker. This failure isn't something we can just train out of the system. It is a mathematical necessity, proven by a theorem that goes all the way back to 1827. The flaw is literally baked into the model's fundamental design. Let me give you an analogy that makes this super clear. Imagine all the messy, chaotic, unstructured data on the internet is like the curved peel of an orange. Now, imagine the perfectly safe, polite, aligned behavior that the engineers want is a flat desk. Well, Gauss's remarkable theorem proves you can't flatten that curved peel onto the desk without it tearing or distorting somewhere. It's just geometrically impossible. And that unavoidable distortion, that little tear in the orange peel, that is exactly why you see these bizarre hallucinations and clever jailbreaks. When you push down on one part of the problem, another part just pops up somewhere else. You see? You can't fix this foundation. You have to replace it entirely. So if the foundation is broken, what do? You don't patch it, you replace it. You move away from the old, flawed building block of AI, and you introduce a revolutionary new one. And this revolution is a move from probabilistic tokens to cryptographic tokens. See, today's AIs run on tokens. They're just unreliable fragments of words based on statistical guesswork. This new model, though, runs on something called tokens, which are atomic units of meaning that aren't guessed, they are cryptographically proven. I mean, the difference is night and day. It's guesswork versus proof. So what makes a token so different? Well, it's made of three unbreakable parts. First, you've got the what, a permanent digital fingerprint, technically a SHA-256 hash, that gives a concept a unique serial number that can never be faked. Second, there's the how. That concept is grounded in a specific, real-world concept. And third, you have the receipts, a verifiable, unbroken, cryptographic history of that meaning. If you take away any one of those parts, the whole thing just collapses. And this rigid structure makes confident lies totally impossible. It creates something called structurally bounded refusal. It means that the AI doesn't have a verified, cryptographically linked answer. It doesn't just guess. It can't guess. The mathematical path to a hallucination literally does not exist. Okay, so we've got this new, super secure foundation. What kind of structure can we actually build on top of it? Well, the answer is an architecture that delivers instant, verified knowledge on an almost unbelievable tiny amount of power. And this is the blueprint for it, the HCNV Colbert matrix. Now, here's the wild part. This system, which holds the key to all this verified knowledge, is designed to be 99.75% empty space. That sparsity, that emptiness, is the secret to its incredible efficiency. It turns out, intelligence isn't about density, it's about having a precise, uncluttered structure. And the efficiency gains from this? I mean, they're just staggering. They're almost hard to believe. Today's big, dense models can burn through 100,000 watts for a complex query. This new sparse retrieval method, the goal is 1 watt. That's not a typo. 1. 1 watt. Let that sink in for a second. That is less power than the tiny light bulb inside your refrigerator. We're talking about replacing a data center that needs its own power plant with a system that could practically run on a battery. So how on earth is that even possible? It's through a concept in computer science called constant time search. Okay, imagine walking into a library with 1,000,000,000,000 books. Instead of searching every single shelf, the one book you need just instantly teleports into your hand. It is that fast and that efficient. Look, a technology this revolutionary doesn't just upgrade our computers. It triggers profound societal shifts. It creates an entirely new economy based on meaning itself. So how would you even govern a network like this? Not from the top down, that's for sure. It would use a model called holacracy, where power is distributed across these nested, self-governing groups. And at the lowest level, you, the user, have absolute sovereignty over your own data. Nothing gets used without your explicit cryptographic permission. This just completely flips today's data economy on its head. I mean, think about how it works now, right? Your data is scraped, hoarded, and used for free. But in this new contributive model, you get compensated every single time your verified knowledge is used to help the network. You actually get paid for your contribution to the truth. And this all leads to a really beautiful and powerful new definition of what intelligence even is. It's not some pile of data that you hoard, like a dragon sitting on a pile of gold. No, it's a flow. Intelligence is what you contribute to make the entire system more coherent, more truthful, and less stressed. Okay, but this brings up a natural, almost chilling question. If we build our digital world on a foundation of mathematically guaranteed truth, where does that leave all the messy, beautiful, wonderful parts of human creativity? Does it kill poetry and fiction and art? And the answer, maybe surprisingly, is a powerful, resounding no. In fact, it does the exact opposite. Having a solid bedrock of absolute, verifiable truth doesn't limit us. It's the ultimate launchpad. It gives us the safety and the confidence to build more wildly, to imagine more abstractly, and to create more freely and more safely than we ever have before.